Hey, hi everyone, welcome back to our daily LeetCode challenge series. So today is day 97 and we are going to solve LeetCode problem 876, middle of the linked list. Okay, so let's see the problem statement first, then we'll go to the solution part. So we have given the head of a single linked list. Return the middle node of the linked list. If there are two middle node, return the second middle node. Understood. So we have given an example of the single linked list 1, 2, 3, 4, 5, basically of size 5, and we have to find a middle node. So middle we can say it is 3 here. So output is 3, 4, 5. Okay, so whatever the nodes going forward from the middle node, that we have to return. Basically, we have to return the middle pointer, and other elements anyways we are going to fetch, right? So here in the first example, the list middle node is 3, so that's why output is 3, 4, 5. Okay. In example 2, we have 1, 2, 3, 4, 5, 6. So total 6 nodes we have, and we'll take, if ideally if we do mathematics, then 6 divided by 2, anyway 3 we have to go, right? So 0, 1, 2, 3. This node is a middle one we are going to take, right? And even example it is return the second middle node. So in this case 3 and 4 both is the middle, but we have to return the second middle node. That's why we are doing 4 here, and the output here we can see 4, 5, 6. All the nodes of, on the onward with the middle one, right? So since the middle node, the same explanation has been given, like 3 and 4 are the two middle nodes of this linked list, but we have to return the second middle node. In the constraint part, we have given the number of nodes in the list is in the range 1 to 100. Fine. Okay, so as per the problem statement, like it's quite clear, like we just have to find the middle node of the given linked list, right? And the thing has to be noted here, like we don't know about the size of the linked list, right? In order to find the size of linked list, we have to iterate over each nodes, and we have to take a counter to store that like amount of count that we are going to iterate, right? And by then we will going to do the half of that size, and then we'll got to know like that is a middle node, then we'll iterate till that node and we'll return that pointer, right? So this is the one of the like we can say basic approach in case of linked list. And as it is a easy level problem, you can approach this part, but we have to think about some optimal approach, right? So that will take some lesser time, because iterating over the linked list to getting face the size of the linked list, then again half of that element, then again we need to iterate to reach to that middle pointer in order to give the result, right? So that is not quite optimal, right? So we can say here we can use a slow and faster pointer, right? Where we used to have a two pointer, one pointer is getting increased by one size, and two pointer is getting increased by two, right? 2x of the one, right? So in this way, like whenever our like faster pointer when reach to the last one, ideally the last node, then ideally the slow pointer will be at the middle, right? So that approach that we are going to use here. Okay, so let's drop to the solution part. So the list node definition is given, like val will store the value, next will be next, and the other comments part. Fine, this is not required, so let me remove. Okay, so here what I'm going to will take two pointer list node, let's say slow, that will initially it will be at a head, right? And similar way I'm going to take list node fast, let's say fast, and that's also starting from the first one, right? That is the initial one. Now we have to check one condition, like our fast, as I told, like fast pointer will like move 2x, right, in comparison to our slow one. So we have to keep tracking, like fast pointers should reach the last node. At that time we can say like our slow pointer will be at the middle, correct? So what we are going to check, like fast pointer should not be null, and let's say fast dot next, right, should also not equals to null. That means we have reached the like endpoint. If it is so, Then what we'll do, till then we have to iterate slow dot next, right? Like one of size. But in case of fast pointer, we are going to iterate twice. Fast dot next dot next, right? So in this, using this approach, we are basically reach that condition. Once we reach that condition, what we'll do, we'll simply return our slow pointer, basically slow node, right? Wherever the pointer reaches. Okay, this is the one. And we have to like at least check the one edge case, like heads. If it is head equals to null, we don't have to check this further. If head equals to null, we'll simply return head itself. We don't have to check the slow pointer, fast pointer in that case, right? So this will be the base case, and this is the normal case, right? Let's submit and see. Okay, so our both test cases got accepted, and we're getting the expected output. Okay, now let's submit and see complete test case scenarios. So yeah, we can see like all 36 test case got passed and it's 100%, because anyways we have used the slow and faster point approach, and that is going to use a log of n, I believe, right? And anyways we are using the fixed size, so we can say space complexity is 1 and time complexity is log of n here, right? So this is an optimal solution in this scenario. Anyways, wherever we have to find the middle one, or we have to find the mid value even in the list, you can use slow and faster pointer very easily without thinking of much, right? Because that is going to be an optimal solution in all the cases, right? And even this question is like quite common in the interview say, so you can practice much on this type of question. Okay, uh, even I'll add this in the playlist, that 50 most common DSS question we need to at least prepare, right? So that I'm going to add. And even if you know any another approach like other than this slow and faster pointer, you can just comment it down. Okay, so yeah, that's all for today. Let's see you next video. Bye.